Hello students, welcome back. In my previous video we discussed about the various types of errors, and in this video we are going to learn various methods of expressing the errors. The first one we are going to learn is absolute error. Absolute error is nothing, it is the difference between the true value and the measured value of the quantity. Suppose for any length the true value of the quantity is 30 centimeter and we are getting 29.5 centimeter, then the absolute error will be 30 minus 29.5, that is 0.5 centimeter. So there may be a question, then what is the true value of the quantity? How you know the true value of the quantity? So for that we measure the quantity for infinite time, take the average of that, and that is supposed to be the true value of the quantity. So let a physical quantity is measured n times, and the measured values are a1, a2, a3, this to up to an, right? So for finding the true value, we take the arithmetic mean of this value or average of this value. So am for a mean value is equal to a1 plus a2 plus up to n and divided by n. So here m is the mean value, or we take it as a true value of the quantity, since we are measuring just for n times, n may be infinity also, right? So there will be absolute error for every measurement. So for absolute error for first measurement, del a1 is equal to am minus a1. Am is the true value and a1 is the measured value. So what is the absolute error for the first measurement? We are getting del a1 is the absolute error for the first measurement, and this is equal to am minus a1. And similarly for second measurement, del a2 is equal to am minus a2, del a3 is equal to am minus a3, and up to del an is equal to am minus an. So we have to remember that del a may be positive or negative, but absolute error we only take. So there is another term, mean absolute error. Since we are getting absolute different absolute error for every single measurement, so we have to find the mean of the error also. So the mean absolute error is just the arithmetic mean of the magnitude of all the absolute errors. So it is denoted by del a dash here. Del a dash is equal to del a1. We are taking only the magnitude of, right? Del a1 plus del a2 plus del a3 up to del an divided by n. So why we take only the positive value of the absolute errors? Suppose for an example, if we are measuring length and we are getting 18 centimeter and 22 centimeter. For first measurement we are getting 18 centimeter, and for the second measurement we are getting 22 centimeter. So what will be the true value of the quantity? True value will be 18 plus 22 divided by 2, that is 20 centimeter, right? So for the first measurement, the absolute error is equal to what? 20 minus 18, that is 2 centimeter, and for the second measurement, absolute error is what? 20 minus 22 is equal to minus 2 centimeter. So if we have to find the mean absolute error here, in this case, if we don't take the magnitude, we take the sign also, right? So 2 minus 2 divided by 2, that is 0 here. So it cannot be 0 because we are not getting the error 0 here. If for one measurement we are getting 18 centimeter, for another measurement we are getting 22 centimeter. So for that case we are taking magnitude for only magnitude. So here, if we take the magnitude here, right, then 2 plus 2 divided by 2, that is 2 centimeter here, right? So for any single measurement, we may get in the range, the value in the range up to a is equal to am plus minus del a bar, where del a bar is the mean absolute error, right? So next one is relative error. Relative error is also called the fractional error. So it is the ratio of mean absolute error, we are just finding here mean absolute error del a bar to the mean value of the quantity. So relative error is equal to del a bar divided by am, where am is the mean value or the true value of the quantity. And next one is percentage error. A percentage error is nothing but it is when the relative error is expressed in percentage, then it is known as percentage error. So when you have to find the percentage error, you always remember that you have to find the relative error, and you just multiply it by 100%, and simply this is as simple as that. 100, you just multiply by 100 and you will getting the percentage error here. So we are taking an example here. The refractive index of water is found to have the values 1.29, 1.30, 1.34, 1.35, 1.32, 1.36, 1.30, and 1.32. So calculate the mean value, absolute error, and percentage error here for the measurements. So the solution is, first we have to find the mean value. In every case, to find any error, this is absolute error or percentage error or relative error, we first only have to find the mean value of the quantity, right? So for the mean value of the refractive index is mu m. This is we just sum it up to the 8 measurement, and we take the average of that. This is just 1.327, and we round up it to the second decimal point, and we are getting 1.33. So absolute error for the first measurement, the first measurement is 1.29, and the mean value is 1.33. So the first absolute error for the first measurement, del mu1 is equal to 1.33 minus 1.29. This is 0.04. And the absolute error for the second measurement, similarly, the second measurement is 1.33. So 1.33 minus 1.33, this is 0. Similarly, we are finding the absolute errors up to the 8th measurement, and we are getting the values as given here, right? You can pause the video and take the note of that, right? For finding the percentage error, we have to first find the mean absolute error here. So for finding the mean absolute error, del mu1, we take only the magnitude. Don't take the sign, negative sign here. So we take the magnitude of every absolute error, and you sum it up and take the average of that, and we are getting the average of this mean absolute error is 0.02 here. So we are getting the mean absolute error as is 0.02. So for percentage error, delta mu is equal to delta mu is equal to delta mu bar divided by mu m into 100%. So delta mu, that is the mean absolute error, is we are getting 0.02, and what is the mean value of the quantity? We are getting 1.30, and into 100%, that is plus minus 1.5%. So always indicate the plus minus here. So we are getting all the values. First we have to find the mean value. We are getting 1.30. Absolute error for every measurement we are getting. We also calculate the mean absolute error, and we also calculate the percentage error here. Okay. So it's all for today. We'll conclude this first chapter in next video. So stay tuned to the channel and please share it. Thank you.